Hey, Mr. Miyagi-Style. Happy Thursday, guys. It's almost a weekend. So, as I promised, this is the third part of 3D Printing 101. It's going to be a doozy one. The first one, I just kind of introduced you guys to the 3D printing world. And the second one, I just kind of talked a little bit about the different types of machines, different types of printers. So we have the FDM printer, and then we have the resin printer. Now, my focus and what I'm going to be doing on is FDM printers because that's what I have and that's what I've been using. I've only used the resin printer once, and I'm not used to it. I'm not a pro at it. I don't know much about it, so I'm not going to tell you or teach you guys something I don't know. I do know FDMs quite well. Basically every part of that bloody machine, I've repaired or replaced. What I'm going to go through today is it's going to be, we talked about the machine, so now you're comfortable with the kind of machine, you have an idea of what you're looking for, what you're going to be doing with the 3D printer, what kind of prints you're going to be making out. This segment is going to touch base on getting an object and then getting that object 3D print ready. Quite a bit to it. I'm not going to get into too many technical aspects of how to do it yet. I'm going to have a sort of a screen capture, and I'll show you a quick sample of from A to C where you get a 3D object. It's just not, you just can't take it and just throw it in a printer and it'll print it out. It doesn't work that way, unfortunately. It's not that easy. There's a lot of process in between, and it's all software based. You need to get used to the idea of of 3D objects. We're not working with flat things anymore. We are working with a three-dimensional object. So initially, everybody thinks, oh, it's so easy. I get into 3D printing. I just download the file and I can just send it to the printer, put it or connect it to the printer on my computer, and then or put it on a memory card and just print it out. It doesn't work that way. There's a few things that you have to do to prep the 3D object to go into a print-ready phase, and I'll go through that in layman terms with you. I don't want to get too technical because it's just going to fly over your head like it did with me when I asked somebody who was a pro at 3D printing to help me with kind of tutor me. He went past me so quickly that I'm like, what? I'm an on hands kind of person. I need to do it and know it and learn it that way. Some people can listen and learn. I can't do that. It doesn't work that way with me. My brother-in-law has two little kids, and they're I think 6 and 8 years old when he got into it, and they saw what I did with my 3D printer, and they decided they wanted to get into it. And they said, oh yeah, we're gonna get our kids a 3D printer for a Christmas present. I'm like, okay, you know what's involved, right? He goes, no. So I kind of sat him down and kind of just give him a little tidbit about what it's all about, what you have to do, and he's like, what? So they just kind of download the print ready files, what they can find, and then they just put it on the disk and they just print it out that way. It's easy to do it that way. You can do it that way and get, there's not much creativity. You're just printing what other people is making. And plus, you also need to know a lot of things about the printer. You need to know about the settings, temperature, layer, thickness, supports, interior supports, that kind of thing. You need to know all that stuff. And I'll go through that with a quick excerpt. At the end of this video, you're going to see me just kind of a screenshot. I'm just doing a screen capture of what I'm doing to get from a 3D object into a slicer, and then from a slicer to a printer. So those are the steps that you normally have to do to get a product printed out, whether you designed it or somebody else did. So there's quite a bit of steps that you have to take. That said, he was a little bit intimidated. It is a very intimidating hobby. When you look at everything at face value, you're like, wow, there's quite a bit here. But I guarantee you guys, once you get the basics down and you get that first print out, it's rewarding, and then you'll learn as you go, as I did. Try to troubleshoot if you're getting rough surfaces or getting rough walls, it's too hot, that kind of thing. And I'll go through that with you as we go. And I want to start from the basics and go up. I don't want to jump the gun. Because if you jump the gun, you're going to miss a lot of steps, and when something does happen, you won't know how to troubleshoot those issues. And I guarantee you there's a lot of trial and error with 3D printing. You're constantly troubleshooting, and why is it this way? So many variables that could push out a bad print. You could have one great print and the next print is like, what? It's completely different, right? And that depends on many things. It depends on temperature, the print head, and it also, believe it or not, it really depends on the brand of plastic you use. We use PLA for our FDM printers to print. They come in the spools, and every brand is different because they have different heat variations and heat tolerance. So that could cause issues with printing, and you'll know that you'll know when you have when you buy cheap plastic and when you buy decent plastic. There's also different levels of plastic. So there's PLA, there's PLA plus, and I'll go through those with you. There's also different types of plastic. There's the UV rated plastic, which is the ABS, and the PETG or PETG. They're really hard to work with, and I'll go through those with you. And then if you really want to get into something a little bit more headache, which I don't really dabble into, I've done it, and I'd rather not. It's TPU. TPU is basically almost like a silicone almost, and you can actually do that on these printers. You can do it with resin printers as well. To do, like, you can print phone covers and things that they'll stretch. I don't get into it just because it's a really finicky plastic, and you have to print it very slow. So your print time is forever, basically, to print TPU. Anyways, I won't get too much into that. This segment is to show you when let's say you find your printer, and if you guys need any suggestion on what printer to get, or if you're not sure about a brand, let me know. I've been through all the brands, like the Anycubics, I've been in through the Enders, I've been to G-Tex. There's so many different brands. They're all pretty much the same mechanism, with slight variations, slight differences. I have the G-Tex, and I love the G-Tex, and they're hard to find now. But there's other brands that are almost identical to G-Tex. It's just rebranded in a different name. If you have any questions in terms of what to do or what to get, like if you're not sure about a machine, just drop me a question down in the description. I'll answer it as quick as I can. Also, the way to get plastic. If you guys want any suggestions, I find that Amazon's the best place to buy rolls of 3D printing plastic. They always have deals, they always have sales, and I usually typically pay about an average of about $18 Canadian to $19 a roll, which is very cheap. And that'll last you quite a long time, especially when you're just getting into it too, right? So for me, I blow through plastic like crazy. I print so much stuff. The trial and error part, we'll get through that as well. So you've got your printer picked out. You want to know what to do next. There's a couple things that you need to download first. Now we're going to get into more of the software part of the 3D printing. This is probably 75-85% of where your work is going to be. It's the software. When you download a file, there's two main files really in the 3D printing world that when you download the 3D object files, they're either OBJs, which is usually pushed out by 3D CADs or 3D rendering software. It's a three-dimensional file format as opposed to JPEGs or PNGs and that kind of thing. So those are the 3D file format. There's other ones too, but these are the ones that are most popular file formats for 3D printing. Typically, when you go in, and I'll give you guys sites where you can download free objects that you can just print out, and so you don't have to make your own or design your own. There's plenty of free stuff out there for you to download. Like you can pretty much get anything. There's a couple sites that I exclusively go to on a daily basis that I get stuff. You can get like Marvel comic stuff, like Star Wars, Darth Vader stuff. This is free. You get like TIE fighters or X-Wing fighters, or I'm a big Star Wars guy. R2-D2. Ooh, look at that. And then I'm a big gun fanatic. So hey, you know what this is, right? This is the Han Solo blaster. And these are in different parts you put together and you paint. That's the other thing too, post work. I'm going to go through, well, we'll do that in the next segment, what you need for post. So when you print something out, what do you need to do to finish that product? Because when you print something out, it's plastic, it's not finished, it's rough edges, it's supports. When you tear the supports off, you're gonna have to sand down, smooth out the edges, that kind of thing. So there'll be post work almost 95% of the time. And then if you want to do painting, You can do painting as well. I do acrylic painting with these. Acrylic works fine on these. And then I do airbrush as well. So if you need any suggestions on that kind of stuff, just let me know, and I'll post it out for you, or I'll answer your questions for you. Acrylic paint I buy cheap at the dollar store. I got like, I'll show you a picture of a video. I'll take a video of the setup that I have for post painting. I have 2 airbrushes, compressor, I have acrylic paints. The one thing you have to realize that acrylic paint is water-based, it's not oil-based. So it's easier to work with in terms of painting and washing and cleaning the brushes and going to the next color. As for oil, you don't see oil paint too much anymore just because it's toxic. And oil is really finicky to work with because you can't just wash it away with water. You need a solvent to clean oil paint, which is not really great for these. Now, the beneficial of oil paint is that it's pretty much waterproof once you put it on your product or your object, whereas acrylic is not. So what I tend to do is I just go and I buy cheap clear coat, like spray can. And if I want to keep something for a long period of time, like this stuff, everything that I paint, everything is clear coated. So once I've done all the painting and it's finalized and it's good to go, I'll just do a light coat of clear coat on the thing. So it preserves the paint. It protects it from moisture, water, that kind of thing, and it actually hardens a little bit, gives it a little bit more protection on the models too. So just things like that, and I'll go through those with you as well, and that's later on in the segments. Today we're going to concentrate on software. So once you have your printer picked out, you bought your printer, what are you going to do? Now, you're not going to be probably doing much printing. You're probably going to do a sample print that the printer comes with. It comes with a memory card with a file. You print it and just to test out your printer, make sure it's okay. You don't need plastic. Plastic doesn't come with your printer when you buy it. So you need to have to buy that as well. Once you do your first print, you're pretty much not going to do anything else afterwards because all the stuff that you download off the internet, they still need to be processed. They need to be sliced. They call them in the industry, in print industry, they call them slicing. So slicing requires software. So you're taking the object. So typically a file you download off the internet is called an STL file. It has the STL abbreviation at the end, the format, and it's a printer 3D file. And those are the files that we tend to work with most. Okay, most of the sites that you see, like Cult 3D or Thingiverse or those kind of places, Patreon, will actually put out STL files. You'll see them in OBJ sometimes, sometimes in 3DS as well. But STL is probably the most universal file for printers. So when you bring that file in, when I first bought printer, I thought, oh yeah, look at all these files. I download the STL file, put it on my little memory card, plug it into my printer, and I can print. But it didn't show up on my printer. I'm like, what the heck's going on? And then I dig deeper and deeper, and I'm like, I had learned this all by myself. Like, there was nobody there to teach me, right? And I thought it was that easy. And so when you guys get your printer, don't think it's that easy. When you guys get your printer, the STL files are it's just the beginning of getting it out to your printer. So you need to take that STL object file, the three-dimensional object. So this will be darthvader.stl, let's say. And you need to put it into a program. Now, there's a couple programs out there, what they call them slicing programs. So what it does is it actually takes the STL or OBJ file, and actually basically it tears it apart, and you go inside and you do all the configurations of how the printer is going to print inside and outside. Okay, and I'll show you that through the software at the end. I'll go through it very quickly. I'm not going to get into details, and we'll get into more details as we go into things that you look for. There's literally hundreds of settings for the software. You really only have to worry about a handful, and that'll get you by, unless you want to get into more detailed stuff and more complex printing features, that kind of thing. The STL file that you download off the internet. So now you have this darthvader.stl file. What do I do with that file? The software that I use mostly, and probably the most popular out there, is CURA, C-U-R-A. It's what they call slicing software, and it's free. It's completely free. It's an open source software, and it has the most configuration, and even has printer profiles. What I mean by that is every printer has different profiles, meaning that there's codes that they send to the printer to do certain things, initialize the printer, print a test line, that kind of stuff. And we'll get into that later on as well. And they pretty much support every printer that's out there. Even my G-Tech was on the list, right? And then there's also the platen sizes. So it has to accommodate for platen size, how big your maximum print size can be, whether it's a Y-axis, a Z-axis, or an X-axis. So it has to do the platen size and also the height. So some printers are higher than that. I have two printers. One is smaller than the other one. So it's just a tad, it's about 2 inches bigger. So I can print 2 inches larger in terms of objects, which is great because less plastic, less printing, well, not less plastic, but less pieces to print if you can do larger scale size prints, that kind of thing. That's why I have two. And I do a lot of stuff that I sell on Etsy. And the one thing that I do sell is 3 print processes. So it's actually just 3 segments. It's designed in a way because it's 3 different colors. So each one print does one color, one print does the other one does the other one. So 3 separate prints. To do it on one printer, which I used to do at the beginning, it took forever because, you know, you're looking at about 3-hour print per segment. So just like 3 times of that, that's like 10 hours of printing, right? If I have 2 printers, I could reduce that time. I can push out more products with 2 printers because I have 2 going at the same time, and then I just do the third one on the one that finishes first. So things like that. Once you get that STL file, you're going to bring it into the software CURA, and I'll show you on the example at the end in the software how to do it and what I do. And I'm just going to go through it very quickly, and then we'll reverse back, and then we'll start from the beginning, and then we'll go through it a little bit slower for you. This is just to give you kind of an idea of what's involved before you spend that money. You might look at it and say, "Holy shit, that's a lot of work." You know, to do stuff, and you may just drop it, right? It's not for everybody. You do have to be very patient with this hobby and a lot of tolerance for this hobby, and there's a lot of swearing, a lot of coffee, and a lot of alcohol when it comes to 3D printing. Trust me. I'm drinking coffee right now. So once you get the object file, the STL file, you bring it into the software. So what happens in the software is when you bring it in, you're going to start from the bottom layer up. Okay, so this sits on your printer platen, and it prints this way, it comes up, right? So you'll see things like, I'm just going to move this over so you can actually see. So what this software does is it hollows out, it basically tears this model apart, okay? And then you determine how to print the inside and outside of the object. Because some things that you print don't require a lot of strength, like this. This is just to put on my shelf, and it just looks nice. I don't use it for anything, right? So it doesn't have to be tough, okay? So that's where the software comes in. Basically, when I did this, the inside is hollow, okay? Why is it hollow? Because I don't use this for anything. It's not designed to bend or use for everyday stuff. And we'll go through that. The stuff that you do use, you don't want it to be hollow, because the more hollow your object is, the more weak the object is. And then you can determine how many layers of walls. So so your printer prints this way, right? It's basically like an inkjet printer, but it does layer at a time, and it keeps going up until the end. Right? It goes around and goes up, right? How many walls do I want this object to be, this model to be? Now, again, I don't use this. It's not designed to be strong. It's just to display on and it's just going to sit there. Nobody's going to use this. So you want to have the least amount of walls possible. You could technically do this with 1 layer of wall, but the problem with that is you could have some artifact that you could actually, it's too thin that you can actually see through, or it could miss a line and you could have a hole. So your safest bet for something like this is 2 layers of walls, just to make sure. 3, I would go 3 maximum for something like that. I wouldn't go any more than that, because don't forget, the more walls that you print in, the more time it's going to take for you to print this object. The goal of printing anything is to balance time and strength. Okay, so if you have something that's strong and you have let's say 6 layers of wall, it's going to be, the shell is going to be super strong, right? It'll be hard. Like this one, I can press my thumb. Oh, I just cracked it. I can press my thumb on it. It's kind of wobbly or soft, I could literally put my thumb right through this because it's only 2 layers of wall, right? If you have 6 layers of wall, this wouldn't press down. It would be pretty tough for you to put your thumb through. So that's the idea of what you can do with an object. And that applies to everything that you put in the software. This is what you're doing with this 3-dimensional object. You're determining how you want the object, how strong do you want it, how weak do you want it, and you need to find out what you're going to be doing with this. It will heavily depend on what the conclusion of this object is going to be. Is it going to be just sitting on a shelf for display, or actually going to use it? You know, I built hangers or you know, things like this, holsters, GoPro mounts. Those things I use on a daily basis. So you want strength, right? And you're going to sacrifice time for strength. Whereas this one, it's a display. I'm going to sacrifice strength for time, right? So I don't need this to be strong, but I can print this a lot faster, right? And this is small because I have models that are quite big. They come up to here. I think the highest model I ever printed was about this high. The higher you go, the longer it takes to print because the printer is going upwards, right? It's actually faster to do horizontal than it is to do vertical. So anything that's high will take up more time because of how it prints. It goes up layer at a time. So that's the strength of the wall. Now, the other thing you have to do, I'm going to go through 3 things. I'm going to stop at that because there's a lot to take in. And I'll show you guys on the software at the end what I mean by, I'll go over what I just went through with you. So we determine the wall, the amount of layers of wall for an object. Now, second most important is what they call infill density, okay? Infill density is what's going to be inside, okay? So we've determined the wall, the outer layer, strength, and now we're going to look at infill density. Infill density is what's inside anything that you print. You can print something as solid plastic, but what's that going to do? That's going to take a lot of time because it's filling in. It's going to be a solid product. Where would you do something like that? Something small, like GoPro mounts or camera mounts or stuff like that. You don't want to have hollow inside because it could snap, right? You want to be a dense object when you print. And those are small enough, like for example, so this is my Insta360 GPS preview remote. I created a frame for it as a hanging frame, and it has a GoPro or finger mounts on it. So this is completely solid. It's not big enough to be hollow anyways. Anything like that, you should be solid. Because it's solid plastic, it's gonna be stronger, right? It won't snap as easily. It won't bend as easy. It won't crack as easily. So things like that, you wanna be solid. This solid? No, this would take, like this probably took me 4 hours to print. And it's hollow, right? If you solidify the inside, even if you filled it with 50%, this would take probably 3 times the time to print. So it would take 12 hours to print. I don't want this to print. What a waste of time. You know, I'm just going to paint this and throw it on my shelf. What do I need to print for 12 hours, right? You know, for people who are doing like mask cosplay stuff, like helmets and stuff like, yeah, you want to probably do, and those will take, those, they can tell you, they take, and I've done a cosplay. I've done a couple, a few helmets and a full costume. Dude, it takes months to do. Printing time is ridiculous, and then you got to do finishing time and painting and everything like that, right? So, but we won't get too much into that. The infill here is hollow, and literally it's hollow that I can press my fingers hard enough that I would probably break this thing because it's just hollow. You can actually kind of feel it. It's soft, right? Now, to make that even a little bit tougher, if I don't want it to be soft like that, you know, if you have kids around, whatever, and they're playing with it, and you want to make it a little bit tougher, I would strengthen up your walls, go to 3 to 4 layers of wall, and I would get into something like an infill, like maybe a 20% or 25% infill. And what that basically means that 25% of the inside of that object will be plastic, okay? And you can do it in different patterns, right? And I'll show you that on the computer as well. You can do it in cross patterns, you can do a triangular pattern, you can do it in wave patterns, and each pattern has their own strength tolerance. Typically, the most used is a triangular one and the grid pattern. Those are the 2 most widely used ones. You can use gyro, which is like a wave. They're supposed to be good for things that you want a little bit of a flex. So you can determine things like that when you're doing your object, which is really cool. If I want this to be a solid product, I could just put 100% infill. Poof, it'll be just solid plastic. But first of all, it'll take forever to print. Second of all, you're wasting plastic because, you know, this solid would probably take up half your roll of a full 2.2 pound spool of plastic, and it would be super heavy, but it'd be strong. But you have to determine what you're going to do with the inside of these products. Okay, so that's what the infill is to adjust the inside of an object and how dense do you want the inside to be, which equals to strength. Okay, so that's number two most important thing. There's three things that are most important, and the third important thing is, and you'll know you'll love this. You'll run into it as you get more advanced in printing and more complex models, is supports. Okay, what I mean by supports is, let's say if I'm printing this. Actually, let me get a better example. Mrs. Darth Vader here. Well, you'll notice that there are overhanging objects like her cape, her arms, and her foot here. Okay, when you're printing plastic, it goes from bottom up. When you're going bottom up, the nozzle just prints this way. When you have something that's overhanging, the plastic doesn't have a base to start printing at. But what it'll do is, if I don't put a support on her foot here, okay, which is kind of lifting up here, when the printer nozzle gets up to this point, it'll just squirt the melted plastic out, but there's nothing underneath to hold it. So what's going to happen? You're going to get strings of plastic until it actually starts building and building and building and building, and it creates a base on its own, and then it'll start printing. Why don't you do that? Why do you create supports? Because if you do that, the foot's going to look wonky because it's all going to be just spaghetti at the bottom, and that spaghetti will eventually form into a foot. So that's not very accurate for that print. What a support does is you can add supports, and you'll see that in the software, and I'll show you. Places you can spin your object around the software, and the spot where you see red, it's where the software is requiring you or suggesting that you put some sort of a support there, because it's an overhanging part of the object, which there's no basis for the plastic when it comes out of the nozzle to stay, and it'll just drizzle down. You need to create a support, and what it'll do is a support. Let's say if I put a support on our foot here, it's going to create, and on the software you'll see it'll create like a little shaft, like a little what do you call it? Like a little square or round shaft from the foot to the base of the print. And it will start that support from the base of the print and go up, right? And you can adjust how that support works, like roof density, how dense, what pattern the support's going to be. And you want to learn how to optimize supports, because again, support is extra plastic that's going to be thrown away. It's just there to print overhanging spots properly. Okay, once you print the object, you actually break that support off and throw it away. Okay, and then you have the open, or you have the hanging foot. Look at her cape. That's another part too, right? Her arms. You know, those are difficult areas to create. And you can have a support that goes all the way up. If you look how far it is from the base to her hands. So you have the stick of support that goes all the way up to her hands. And that's plastic that's going into the garbage, because that's useless. It's just there to serve a purpose, and then it's thrown in the garbage. It's no use anymore. Now as you learn to make these models and print these models, you find ways of, the goal is to use as least support as possible. And how do we do that? Creating or finding objects that are designed so no support is needed, even though there's overhang parts of the model. Now, what I mean by that is your printer can print overhangs at a certain angle without the plastic dripping down. I think it's 30 degree angle. So if you can create something that's at a 30 to 40 degree angle, you won't have that problem where the plastic will just drip down onto the base and create that stringy spaghetti. Okay, because it can actually layer itself on a 30% incline or 30 to 35% incline, and you'll find places like Thingiverse or Cults, they will have models like this. I'll show it for example. This is what they call a no support model. Okay. What they mean by that is, see this his arms, I think that's 30 degrees, something like that. I think it's 30 degrees. So see this arm? It's kind of overhanging, right? But it's on it. Excuse me, it's on an angle that it doesn't require support. The printer will go in circle and it'll actually print almost on an angle. Like it'll just move out a little bit as it prints the lines, because that's what initially what a 3D printer does. It does line at a time of plastic. That's all it is, right? So it prints the line a little bit out, until it creates an angle, and that's the angle right here, right? So that's one way to make your designs, create designs or models to deter away from using supports, because supports does require more time to print and it's a waste of plastic. So all supports are thrown away, they're not kept, okay? But yeah, like this is, and you'll find models on the, and it's some pretty neat stuff. So this is a Batman model, okay? You see a cape? So this is a zero support model. This is printed out without a support. Look at how that cape hangs out like that. Look at the edges and look at the tips. It's on that borderline angle that you don't need a support with FDM printers. So this was actually printed with zero support. It just printed the whole thing without and I have no waste. And it took less time to print, because again, when you're printing support, you're using more time, right? So things like that you can also create, and you can also find on the internet. I think I'm going to end it there, guys. I think I covered quite a bit. Those are the three bases that you should be looking at. The other thing that you need, and it's going to be a little bit long. There's going to be the software where I'm going to go through and show you very quickly how the process from A to C is to get to the printer, from the download to your printer. And I'll do it very quickly, and then I'm going to go back with each segment and each part of this 101 to get into more details of how you can do it. So that you can actually do it when you have your printer. The other thing I forgot to mention is when you're printing, the first layer and second layer are the most important layers of printing, okay? If you don't achieve, and we'll get into this in the next segment, if you don't achieve good bed adhesion, that's what they call it, that means that the first layer of print that your printer does, if it doesn't stick perfectly on that platen, you're gonna have problems, okay? That's just rule of thumb. If you have a bad first layer, kill the print, start again, and find out why it's not. If it does it again, find out why it's not printing that first layer flat, and it should be stuck to the platen perfectly fine. Okay, there shouldn't be any edges lifting up. There shouldn't be any holes or skips of plastic, that kind of thing. There's always a solution for those kind of, whether you're not aligned properly. The nozzle has to be on all four corners, the center of the bed. Your nozzle has to be perfectly leveled, okay? So meaning that when it prints, let's say if it prints a big square, each corner has to be the exact height from the nozzle to the bed. If you're off a little bit, if you're tilted off, and I'll show you how to do auto bed leveling or manual bed leveling. We'll get into that. That's very important. That's probably the most critical part of your printer, and some of these new printers have it. You can buy printers that have auto bed leveling, and they work pretty good. It's just almost like a little laser device that's connected to the print head, and it actually goes through the process and levels you. But I don't have that. I do it manually, and I'll show you how to do that as well if you don't have a printer that has auto bed leveling. So meaning that your nozzle has to be level on the bed on all four corners. If it's all level on all four corners, then your center is always going to be level, right? Because all four corners are level, provided that your bed is completely flat. There's been issues in the past where people have used beds for the longest time and the bed has warped. So if your bed is leveled, you should have good adhesion, first layer adhesion. And if you don't have first layer adhesion, it's going to throw the rest of your print. So don't write it off saying, oh, that's fine, it'll be okay, because that little bit, it's like a domino effect. That little bit of lift or off leveling will affect the rest of your print as it goes up, right? There's been cases where I print and that the edge is kind of lifted up, and that's fine, and I'll press it down, right? But then I go back and it's caused such a problem on that corner that the whole thing lifted on a corner of the object, and you got this kind of a weird warping sensation on the left hand side. It gets better, it gets to the top, but the first half is all screwed up. It doesn't look very good. We'll get into that as well. So anyways, I'm gonna cut it off, and we're gonna go to the software part. And if you have any questions, guys, drop me a question down in my description. I hope this wasn't too long. There's a lot to cover, guys. We're just at the tip of the iceberg for 3D printing, so there's so much more. If you have any questions in terms, if you're ready to buy a printer and you have questions in terms of what printer, what plastic, what else you need to buy, any upgrades for your printer, there are a couple things you need to upgrade on that printer when you buy it. It's very important. Just drop me questions down in the description. I'll answer as quick as I can. Anyways, guys, gals, have a good day. Enjoy the video. We'll talk to you on the fourth part. Ciao. All right, guys. I'm just gonna do a quick video on this. So I've got I think set up here with the two pieces of, well, the one piece of software. So what I'm going to do is I'm going to show you a sample of, let's say, for example, I'm downloading an STL, an object, a three-dimensional object from a website. And I'm going to use Thingiverse. Thingiverse is probably one of the biggest sites for downloading free things that you can print. They've got everything on there, accessories, models, you name it, they have it on there. And 99% of the stuff is free that you can download and you can print. You can even alter it if you want. So I didn't mention on the video earlier that there is a third piece of software. The software that I'm talking about is the actual creating 3D products software. We'll get to that a little bit later. That's probably something you want to start doing a little bit later on as you advance yourself with 3D printing. So let's get you started with getting an object and getting it to the slicer, and then from the slicer to the printer itself. This is the important part, right? And we'll get into the creative part later on, and I'll concentrate on that. I use it exclusively. It's free. It's an online software called Tinkercad. And you can do it with 3D software as well. There's a lot of software out there that's free, quote unquote. There's some that they charge for. Anything that you can create 3D and export out to 3DS, not 3DS, into OBJ or 3D, yeah, it is 3DS file, 3D files, object files, three-dimensional files, that kind of thing will be fine. You're gonna take that file and you're gonna put it in a slicer, and now slice it out into the actual the file that you use for the printer. And the file format we use for the printer is actually .g code, so it's .gcode. That's a 4-letter format. So that's a code that's actually the printers will recognize, and then will print from that particular file format. Anyways, let's get on with this. I don't want to be this too long, so I'm going to go through very quickly with you. So I'm going to go on the website called Thingiverse, and I'll drop the link down in my description that you can go in and kind of explore a little bit. And there's literally thousands and thousands of stuff that you can download there. There's a couple other sites which I add on later on, like Cults 3D, that kind of stuff, and Patreon. But this is the big one, and it's free. So for example, if you look on my window here, I've got Thingiverse on here. And I'm just going to use the Darth Vader one because I like the Darth Vader one. It's a good example to use for supports, and you can do walls and infills and that kind of stuff. So this is the one that you saw earlier that I actually used to print out my model. And if you scroll down, if you go to the file section right here, you'll see on here, there's usually several files on here, and they describe by the file on here. Now, I'm not sure why he has two, but they look like the same files. And you'll notice here it says STL. So that's the file you want. And when I'm going to go to right here, I'm going to hit download. And it's just going to say Darth Vader bus body by Eastman .stl file. I'm just going to save it to my default drive, which is disk 1. And the file is saved on here. Okay. So now I'm going to go to my other program, which is the main one, the CURA. Same company. It's the same company that owns Thingiverse. It's the Ultimaker company. This is the software I'm used to that I started from the beginning. I love it. There's other software too for doing slicing of or prepping your objects for 3D printers. But this is probably the most widely used one, and I think, in my opinion, it's the easiest to use. And it looks intimidating at first. It looks like kind of a 3D software. It is kind of. If you look on the left, it's actually the immediate tools for your object. And on the right over here, it's all the, yeah, there's literally hundreds of configurations, formatting and that kind of thing for how you're gonna print out your 3D print file. We're gonna start with the star, which is the main ones up here, and we're gonna concentrate on a couple categories only. And again, guys, I'm just going through this very quickly, and this is kind of the process you have to do to get your file onto the printer and then print it out. I'm not going to get too much details into CURA, and we'll go through that as we go with the segments of this 3D printing 101. I'll get into more detailed sections like quality walls, infills, supports, that kind of stuff later on. But just to give you an idea, so first thing I'm going to do is I'm going to go to the open file folder here. I'm going to open up the file that I just downloaded, which is a Darth Vader one. And you'll see how big it is, right? It's kind of relatively big. So I'm gonna click on it. It's gonna give me this. So this is the move option default, so I can move it around the platen. And you have to stay within this gridded platen, okay? Because that's your printer bed right there, okay? If you exceed that, it's not gonna work because it won't print properly. Let me just go up to here. I'm gonna change that error message here. It's pretty big. So if you look at this object, you know how it's kind of angled right now. Okay, and you'll look at the bottom right hand corner. It says slicing. So what it's doing is doing a configuration for the printer itself. It's actually manipulating the object for a 3D printer. Okay, in terms of walls, infill, supports, etc., and all the details on the right hand side here. It's pretty big. Look at this. Right now, if I leave it at default at 0.22 layer height, which is medium, with 3 wall counts, infills, blah, blah, blah. This is the default setting that I have on my CURA. Look at the print time. It will actually give you an estimate print time and the estimate of how much plastic it's going to use. Now, if I leave this as it is, it's going to be 8 hours to print this object. Okay. To give you a detail of what this looks like, okay, I'm going to go to preview. And you'll see it kind of changes the image a little bit. I'll zoom in a little bit. Under here, there's a slider. I'm going to go all the way down. This slider here is your print head, okay? And you can actually play it. Print head, this is from layer 1 all the way up to, it tells you how many layers. It's actually 775 layers of print. And you'll see as I go up, look at the inside, the infill. That's a lot of infill for a model like this, right? That's probably why it's 8 hours. You don't need this kind of, that's ridiculous. If I drop this infill, if I go to 5%, look at what happens on the right hand side. I change the infill density to 5%. Look at what the pattern does. It changes on the object itself. And look at my print time. It's going to go down significantly just because I'm doing less fill on the inside. You can go 0. See how it used to be all gridded? Look at how much time it dropped. It went from 8 hours to 5 hours, and I just changed the infill. And I haven't done anything else to the object itself. Walls, supports, that kind of stuff, right? Just give me 2 seconds here. The more you change configurations, it will affect your time in print. And you'll see on here that it actually prints from. Remember, the grid was really quite dense. Look at it; it's hardly any grid. And I can go 0. If I go 0, let's see what my time is. It's going to drop the time probably down to about 4 hours, I would say. Yeah, look at it. It's 4 hours and 42 minutes. But look at the there's nothing. It's just a shell. It's just printing the shell, right? Yeah, you drop from we've dropped just by the infill. We went from 8 hours to almost half the time just because of the infill. We haven't even touched the other stuff like wall counts, supports, that kind of stuff, and then layer height, layer adjustments, all those other configurations. Now, if you look at this, it's empty, right? What happens is when it's empty like that, the inside is quite weak. So you have this 3-layer shell, because right now I've got 3 walls. If you look on the right hand side, look at here, wall line count, I've got at 3. Okay, right here. So if I change it to 2, watch the walls, that's going to change. Let me blow it in a little bit. So look at the walls. See, it's 3 lines, 3 and 2, 3. If I change it to 2, it's going to drop my time down even significantly, and you'll see it change on this image here. Drop down about half an hour, but look at the walls, 2 layers now, right? Essentially what we did was we took out the inside, we made it hollow, we made 2 walls. This thing is going to be very light. It's going to be relatively weak. but it's just going to sit on a table or on a shelf to display. Don't need it to be strong. So we cut our time from 8 hours to half the time. Now I can make it even less. Right now I'm going to go back to prepare. So this is the actual object before it's on preview. It's relatively big. You have the measurements on here, and it'll tell you X, Y, Z in millimeters on here, how tall it's going to be. So let's make this a little bit smaller. I'm going to go, let's say 75%, and I'll change that, and it'll change uniform scale, change everything. So now I think this is the actual size of the one that I printed out that you saw on my previous video. Look at how much at empty, 2 layers, 2 wall layers, and infill 0 at 75% of the size. Look at my times here. Estimated times now 2 hours and 34 minutes. So I'm changing it from 100% to 75%. I just knocked that time almost half again. And you can keep doing this. You can when you get good at this, as you get more and more used to the settings in CURA, you can start playing with times. Like I can take an 8-hour print and I can make it 1 hour if I really wanted to. If I really spend the time to start playing with configurations and wall line counts and line height and that kind of stuff, you can actually really do that. That's what I meant by earlier when I said there's a lot of trial and error, there's a lot of playing, that kind of stuff, right? Just to give you an idea of what you can do with this. Once I've got this down, I resized it, I've hollowed it out, I put 2 walls instead of 3. And it made a significant difference in time. And look at the material. We went from, I think it was 362 grams of material right here. Now it's at 58 grams. Like that's a huge difference. Look at how much plastic you're saving by doing that, right? And then we can do supports if we wanted to. So if we go down here, if you look at here, right now it's leaning and there's no supports, right? I can put supports on there if I want. So this is what a support would look like. I'll do the supports and then we'll cut it off. And there's a lot of information you guys are taking in right now, and I don't want to overwhelm you with this stuff. On the right hand side, you'll see support section, and if I click on support, it's going to activate support. I'm just going to do touch build plate, and let's see what we get here. It takes a while to configure the support. It's got to figure out the metrics of the whole thing. It's got to figure out material cost, time. So it's actually calculating the support. It's probably going to be a loss. It's going to probably put this whole support on this area. Watch. Yeah, see? You see how it changed? Look at all these. These are all supports. Essentially, what's happening here is because it's leaning, the printer, it's too much of an angle that the printer will just, it won't do this kind of a, it might. It's close to 30-40 degree angle. What you can do, there's a couple things you can, so that's a lot of support right here. Look at how much we jumped from 2.5 hours to 3 hours and 51 minutes just by printing the support. That's a significant amount of time, and plus a significant amount of plastic. What you can do is, I'm gonna show you this the last thing. I'm just gonna end it right there. What you can do, remember I was saying that you can play around with configurations and that kind of stuff to kind of save time, save material. So you notice it's on an angle like this. So watch when I change the angle of this Darth Vader. Okay, I'm gonna go here, and I'm just gonna change the angle of this. By doing this, what do I do? Right? I reduce the amount of supports here. I just added here. It's still gonna sit upright, but let's see if I've made any difference in my time. Definitely material. No, I don't want these on top. What I can do is see these ones. These ones are these long ones. They don't need to be here. It's just because it automatically calculates if it sees red. If you see stuff like this, like red pieces like that, like red areas, it's going to automatically put in, no matter how minuscule, it's going to automatically put in the support. Now, I know for a fact that I don't need these on top, these long ones. So look at my time, 3 hours, 47 minutes, 71 grams, right? What do? I'm going to go back here, and you'll see here, it says block support. Let's go back here. I'm going to drop a box right here. I'll fast forward this. Oh, it did do it. I didn't catch it right in time, so I must have missed it. Okay, what I'm going to do is I'm going to do something even more Interesting. So I'm going to select this one. I'm just going to make one big one on the top. Okay. Okay, now I'm going to move this over. It's not long enough. Hold on. Here it goes. So I'm going to drag this on top. I'm going to cover everything that's on here that had those long supports. See if that made a difference. It should take out those long columns. Yeah, see? Notice that the long columns are gone. I don't need those. I know for a fact that I don't need those. It's not going to be an issue because the angle is good enough that it's safe for the printer to print without a support up to the shoulder here. Now these ones I don't even need these ones here. If you see these ones here on a body, look at where it has the red. Like the printer can compensate for that kind of a overhang. It's very minimal. It should compensate for that. Well, I know mine can because of the larger nozzle. Thinner nozzles may not have that compensation. So I can actually essentially, not this one here, see that there's a lot of red here. It won't compensate for that. For little ones like here, these thin strips of red, yeah, I know my nozzle will compensate for those. I can actually block those out and save a little bit more time, a little bit of material. But you get the gist of what I'm trying to do. Like I don't need these ones at the back. And that saved me this, what, 6 columns and drop my time down to about 40 minutes and drop my material down. Things like that you guys can play with and you'll get better and better at it over time. You'll know your machine, you know your habit, your behavior machine, and what the limits are of your machine. And then from there, you would make those changes to reduce time, reduce material. That's it, guys. That's the gist of getting an object into a CURA to slice it. Couple of things. There's so much more to this, guys. Honestly, we've touched on the 2 things on the right hand panel, and there's literally almost 100 configurations that you can play with, over 100 that you can play with to make changes and to customize and tweak your model, so it's not printing as long and it's not using as much material. And that's a goal, to get the best results with the least amount of time and the least amount of material, right? And you save money that way. Anyways, guys, that's it. Any questions, drop me a question down in the description and I'll answer it as quick as I can. But that's it, guys. That's it for this segment. Wait for the next one. Have a great day. And if I don't talk to you in a weekend, have a great weekend. Respect. Ciao.